He also serves on interagency and international groups aimed at enhancing data sharing and interoperability, including the International Group on Earth Observations Data Management Principles Task Force, the U.S. Group on Earth Observations Data Management Working Group, and the Open Geospatial Consortium. Jeff holds a BA in Physics from the University of California at Berkeley and a PhD in Astrophysics from the University of Colorado at Boulder. Please welcome Jeff.
Thank you very much. A lot of people call me Jeff DLB just to avoid the pronunciation problem. And yeah, I used to be in astrophysics when we only had 100 billion galaxies, so big changes. So I was asked to talk to you about the public sector role in big data for the environment, harnessing big data for the environment. I apologize that I was not able to be here for the morning session or the rest of the day. It was kind of a last-minute addition to this, but so it goes. Can't see this. Is it possible to put this not in the sort of presenter view? Okay, it'll be fine. What I want to tell you about is, first of all, the public sector role, and I found 7 roles that I want to mention. I'm going to focus on NOAA, because that's where I'm from. I also want to tell you a little bit about the NOAA Big Data Project, since this is a big data focused thing, and then a couple of challenges and wishes that I have personally about kind of moving forward from here. So role number 0 is coordination, and maybe it's 0 because it's very fundamental and happens before everything else, or it's 0 because I used to write software and it was always 0-based, but actually it's 0 because I thought of it last and I didn't want to renumber everything else and I put it. All right. But I realized that this was an important thing, which is the public sector and the agencies do a lot on coordination amongst each other and with the international groups that also gather data. So, for example, there is this U.S. Group on Earth Observations, which was actually mentioned in the introduction, which is a White House-led activity with all of the civilian EO, Earth observation agencies. It's done assessments of the observing systems we have and how well they meet the needs of the various agencies and whether different agencies can use data that they didn't collect but that are from a separate agency, that kind of thing. So there was an assessment in 2012. There's a new one being worked on right now. Several documents have come out, the National Strategy, the National Plan, and one that I worked on called the Common Framework for Earth Observation Data, which talks about standards for data discovery and access and so forth. And this group also represents the U.S. in the International Group on Earth Observations. So I think that public sector role is very important, and it's not really something that is going to happen for commercial reasons or even for academic scientific reasons. So really the government has to be the one to do that, I think. Okay, so role number 1 is data production, and this obviously is huge in the big data for the environment realm. NOAA contributes data from satellites, radars, buoys, tide gauges, humans, animals with sensors mounted on them, ships, aircraft, and increasingly numerical models, which are generating more data total than all of these observing systems, especially as we keep ramping up our ability to do simulation. So NOAA contributes a ton of data, that's a big role, but then also the other agencies, NASA, USGS, EPA, USDA are measuring data, large and small, but many types of data that contribute to the big data arena. And then NSF, they don't necessarily measure data or perform observations themselves, but they fund big projects like the Ocean Observatories Initiative and so forth, which also collect big data. So I think that role is very important. I do want to mention one specific observing system just because we just launched it a few days ago, which is GOES-R. This is the first of the next generation of geostationary weather satellites. GOES stands for Geostationary Operational Environmental Satellite. And just on November 19th, we launched this satellite after some delay. There will be 3 more in this sequence, and these greatly increase our resolution and timing and so forth, new sensors, better sensors, compared to the current geostationary satellites up there. So a lot of data, just the raw data, the unprocessed level 0 data is about 1 terabyte per day, and then you add about another terabyte or so as you process that into other products. So it's going to be good. It's launched, and it's in sort of testing mode, but then in maybe 6 months or something like that, it will start really sending us data. So data production is a key role, I think, for the government. Another role which we maybe don't think about is operational reliability. We have to run these observing systems 24 hours a day, 7 days a week, every single day, often with as short a delay time as possible, get the data from the satellite through the ground system and into the weather model, so we can run the weather model, so we can tell you whether to bring your umbrella tomorrow. And this has to happen without fail and as fast as possible. And the government is perhaps the best entity to be running those kinds of things. We have to deal with all the transmission of the raw data from the satellite, the processing, assimilation into the models, running the models, and so forth. So I think that's a very key role for the government, which most entities are not necessarily going to be wanting to solve. Well, having said that, it's true that businesses want their systems to be operational and reliable. But in terms of big data for the environment, I think the government is really the key operator here, as it were. And then role number 3, so this might be the most important one, I think, which is ensuring scientific validity. We have domain expertise in these areas of earth science, of environmental science. We develop the sensors, we work on the algorithms, we improve the algorithms, we try to make them be as accurate as possible, to get as much information as possible out of the signals. And certainly there's a lot of research done on algorithms, but there comes a point where you got to say, okay, this is the algorithm which is going to run in an operational fashion all the time, and we have to make sure it's correct. Make sure the data are of good quality, do reprocessing when we find possible issues, and then long time scale studies. So we're not in this just for quarterly shareholder gains. We are thinking about the science of the planet on a very long time scale. So that's something which the government is very well positioned to do. And maybe that long time scale studies is the new code word for climate, just to get that word out of the vocabulary perhaps. And then also we need to have defensible conclusions. So when we make a statement about what happened, how much rainfall we saw in this month, that's what this map shows here, amount of rainfall in the month of March 2016 when there was some flooding in the south and in the northwest. This is our most accurate statement about what those data values were, and we are able to defend how we got to those numbers. So I think scientific validity is a very key role for the public sector. Okay, so public access and usability. This is something that NOAA has certainly focused on for quite a while, and we're trying to do a better job at. But that's also recently become more and more mandated by the current administration, the Obama administration, on all the agencies. So we've had an open data policy that's come out, which is a memorandum from the Office of Management and Budget, a public access to research results memo from the Office of Science and Technology Policy, and other documents before that, all saying, hey, you need to be sure your data are publicly accessible in a standard fashion as soon as possible and preserved if you can. So at NOAA, we're doing some things with that. We have our various data sources, satellite, radar, buoy, and so forth. And we want to make sure that data gets to the users who want to be able to use their own tools. They don't necessarily want to have to come to our website and use our little user interface that we wrote. They have their own tools. They use R, as was just mentioned, or other pieces of software, IDL, whatever, MATLAB. They want to get into custom tools that they may have built. They want to use their own tools and get our data in there. So what are we trying to do to make that happen? Conceptually, we're trying to build a sort of data services layer with some standardized approach to letting people discover the data, access it once they've discovered it, find that it's well documented so they can understand the data once they've accessed it, and standardized in terms of formats and controlled vocabularies and so forth. So this is something we're working on. We actually have policies at NOAA about this and have made progress in this arena. I wish I could say that all of our data were uniformly standardized and so forth, but we're slowly getting there. In terms of discovery, I do want to mention a couple of projects that we have at NOAA. One is our NOAA data catalog. It's fairly new, data.noaa.gov, and it's too bad I'm giving the talk right now because we're just doing a kind of maintenance and cleanup thing, so I'm not even sure that it's running at this very instant, so I'm not going to try to do a demo. But yeah, we notice all of a sudden, hey, there's 40,000 data sets because something messed up, so now we're fixing it. But by tomorrow, I'm sure it'll be fine again. And this is supposed to be a comprehensive inventory of all NOAA data, and it's almost comprehensive. The number of data sets has been going up with time, and it's sort of leveling off. I think we're kind of getting everything. And it's mandatory. The U.S. Open Data Policy said every agency must have an inventory like this. So in theory, the entire public sector, all Earth observation agencies are going to have some kind of inventory, which in our case is represented by this catalog, and in all cases is also fed up to data.gov, which is the U.S. level catalog of everything, of all the data that we have. Not just Earth observations, but everything. So we've been working on that, and it's pretty good. We'd like to make some improvements. Uses some open source software, and we would like to do better things with it, but it's there and fairly comprehensive. Another couple projects I wanted to mention are the Unified Access Framework and the Metadata Metrics Project. So UAF is something where we said, hey, let's try to find all of the servers that use the DAP protocol, the Data Access Protocol, OpenDAP, and serve gridded data and kind of make a master server on top of all of them, so you could in one place find all of the gridded data and just kind of automatically get to it using the tools of your choice. And it supports a bunch of tools. I don't know if you can read the little logos there, but Threads, Live Access Server, IDV, and so forth, MATLAB are able to read from these servers. So this is a little project that we fund from our office in Seattle, Washington, on getting access to gridded data and also starting now to move into in situ data, like profiles or trajectories from ships, that kind of thing. So that's been a way of improving data access. And then also on the metadata side, we've been trying to improve our metadata, our data documentation. We actually have a sort of metadata metrics engine run out of our data center in Boulder called EMA, Enterprise Metadata something assessment. I forget what the other M stands for. Trying to sort of count how much metadata we have and how complete it is, and scoring it. And the best ones are blue, and the lousiest ones are red. And letting people have tools to actually look at their own metadata record and see what they need to do to improve it to get a better score. So those are a couple projects we're working on. A bigger, newer project, though, and maybe a little more relevant to this forum here, is the NOAA Big Data Project, or BDP. And the URL of the website is there, noaa.gov/big data project. Conceptually, what we're trying to do is this. We've got NOAA data, and I'm including observations and model outputs, and we have some services that make them publicly accessible. But what we've done now is partner with 5 cloud providers: Amazon, Google, IBM, Microsoft, and OCC. That's Open Commons Consortium. They're a kind of academic cloud group. And say, hey, look, we will work with you to copy huge data sets into your cloud so that people can do analysis or visualization or data integration directly in the cloud instead of having to bring the data locally to you. And people can just use the data remotely instead of getting the data, bringing it to their own infrastructure, and then working on it. So, and I really wish I was here this morning because I don't know to what extent you guys talked about, using the cloud and computing on the cloud. And I know, Kristen, you were alluding to that, but I didn't see all the talks before you. So, I'm hoping you're familiar with this idea of, bringing the computation to the data, logging on to the cloud, as it were, and the data are there, and just start computing. And the idea is, NOAA has a bunch of data which we feel may be underutilized. We send it to our weather models, and in fact the weather data do tend to get utilized and have created new industries in the private weather sector, but we have tons of other data which are not weather. And so the question is there latent value in those data which could be brought out if only the data were more accessible? Can people have new value-added products and services on top of these data? So we're trying an experiment, basically, to see if this is true. This truly is an experiment. It's a CRADA, Cooperative Research and Development Agreement, so this is not an operational thing that we've set up yet, although we're trying to figure out, okay, what comes after the CRADA phase. Right now it's a 3-year R&D project. And so our collaborators are these 5 cloud providers, and I'm glad at least one of them is represented here. I don't know, Kristen, if you're at all involved in that particular aspect of Microsoft, but we've got these 5 cloud providers that are sort of the focus of what will happen in these projects. And the idea is that other people can join up with them. So let's say you want to do something, you have an idea, a new product, a use case for NOAA data. You could team up with one of these cloud providers and say, okay, let's get those data onto that cloud so I can do my computing, and maybe I'll be able to make a new product, a new line of business, a new idea, something like that. So we have some sort of ground rules. We make all of our data potentially available to all the collaborators. We have not sent all of our data, but they are free to have all of our data. There's some caveats or some requirements that we won't give exclusive access to any one of these. We offer it to all of the 5 providers, and if they want it, they can take it. If they don't have to. And they, in fact, choose, because this is an R&D with no money exchange. So we're not actually paying to host the data. We're just saying, look, is there something that you feel would be useful, or that you could make some money on if we gave you the data, and then they ask for what they feel they have a use case for. But these are free data, so they can't charge people to come to use the data. They could charge for egress charges, the usual kind of cloud egress charges. So far that actually hasn't been happening, but they do charge for computing time on the data. But people who compute on it are saving having to have brought the data to their own infrastructure and have an infrastructure large enough to handle it. And then if you have a new product on the data, you could, if you wanted, charge. If somebody has a 99-cent app that tells you where the best powder skiing is going to be today, well, maybe people are going to pay for that, even though it was based on free government data. That's kind of a value-added thing. So I know I would, but anyway. All right. So far we've transferred one huge data set, and there's some other stuff in the works, and this is the NexRad L2. NexRad is the next generation radar. You may have seen these sort of spherical dome things at airports, and then they produce these precipitation maps. Here's a mosaic in the background there showing rainfall or other types of precipitation nationwide. So the data have been publicly accessible, but difficult to get traditionally. You could get the current stuff in one place and then the older stuff from the archive, but it was written on tape, so you'd have to place an order, and they'd send you an email telling you a couple days later, okay, come get it. And it turns out it would take more than one day to get 1 day's worth of data, so it was sort of impossible conceptually to get everything. But we made a big push and sort of worked with the Cooperative Institute for Climate Studies in Asheville, North Carolina, which is where the data actually were hosted at our Asheville Data Center, and a big push to get the data off, and it was grabbed by Amazon, and Amazon grabbed all of it. Open Commons Consortium grabbed 2015 and later. And a couple of the other cloud providers have grabbed it, but have not actually announced its availability yet, so I'm not quite sure what they're going to do with that. But in any case, right now, you can definitely go to Amazon, go to this S3 bucket, and get all of the NexRad data for the first time ever in one place. And this is actually huge. What we're seeing is that people are going there. So this is a histogram showing access in... what's the units? I must have crossed it. Oh, terabytes. Terabytes of data from 0 to 100 is that top number over time since 2014, July 2014. So, whatever it varies is the total amount of access per month. Light blue is from NOAA, and then the green is from Amazon. So as soon as we made it available, where that first green bar is, people started getting it there, either getting it or using it there. Not even, mostly they just compute on it. They don't transfer it to their site. And we're finding now that there's more access or more use of the data, and that most of the use is coming from Amazon instead of from us. And we're seeing a decrease of about 50% on our own infrastructure trying to serve this particular data set. So that's just one data set, and people are starting to do some interesting things with it. No real commercial products yet, although there's some groups that are kind of looking into that. But some interesting studies. The one that I found most interesting was bird migration. Apparently, you can see birds pass by in front of the radar, and so you can study the migration as all these radars are observing nationwide in the mosaic. So something I had not envisioned at all before, but there you have it. We're working on some other data sets for the big data project. One is MRMS, multi-radar, multi-sensor, which is a kind of highly refined product from the radar. It's gridded and it finds events like storms and so forth, and it kind of flags all those. Working on making that available. Geostationary satellite data. So I just mentioned that we had launched this new satellite. Trying to figure out how do we get up to 1 terabyte of data to one or more of these clouds per day on an ongoing operational basis without disrupting our current operations, because the idea of doing that was not built into the ground system when we commissioned the ground system and the satellite. So trying to figure out what the best way to make that happen is. Numerical models. So there's huge interest in our numerical models, including experimental models, which normally do not get are not made publicly accessible. How do we make those? How do we make those data available, and how do we ship them out of the building and into the cloud? It's actually a big problem, just because the data are so huge. And then a much smaller data set, but of interest to some people and historically very difficult to get, are things like fisheries catch data. It's problematic because you have to anonymize it, so you can't tell which fishing vessels were out there. But we're trying to figure out ways to properly package such data and make it available, because there's some interest in that. So these are some of the future data sets for BDP. All right, I only put 3 slides for that. I have some more in backup, and certainly if we have questions about that, I can answer them at the end about the big data project. But let me move on to role number 5, long-term preservation. So this is really key. We are guaranteeing that we are going to keep the data around essentially forever. 75 years is sort of the minimum. Ideally, observations we keep even longer. We have stuff that's 150 years old, but we see ourselves as the long-term steward of the data. We're not just going to toss it because it doesn't seem to have commercial value anymore. This is the record of the planet. We need to do long-term studies, especially now as the planet may be changing in the climate realm. We want to be able to see how things were and keep measuring and keep that available so that 75 years from now we can still do that. I have a friend who's got a great slide. He says, these are your users, and it's a picture of babies in a hospital nursery. Okay, those are your future users, right? You have to preserve the data and write metadata well enough so that those little babies someday will be able to use your data. It's a kind of a powerful image. So we have to update the data when we discover, say, a calibration error or something. Migrate to new formats, all that kind of stewardship has to get done, and really the government is, I think, the best position to do that. The graph down there is showing the growth of NOAA's archive, scales from 0 to 160 petabytes, and it's going out into the future. So 16 is 2016, that's this year. A jump in the green with new numerical models kind of coming on board, and then a growth in the blue is the satellite, and the other colors are various other types. But so a lot of data in our archive, and we're promising to keep it around. Maybe not all of the model outputs, because we think some of that you can keep the model and the initialization, but not necessarily every bit of the output. But all original observations should be kept forever if we can do it. Another thing we're doing, by the way, with our archives is starting to assign data set identifiers to allow data citation. So we're assigning these DOIs, digital object identifiers. We've got about 1,000 of them assigned so far. We're doing them one at a time in a kind of manual way to make sure we get it right. And starting to see, okay, is anybody citing our data? So I started counting citations in Google Scholar, and sure enough, it's going up. We haven't automated that yet, but I think we're going to start being able to automate that counting and see whether people are actually citing the data that we assign DOIs to. And I hope get to the point where all data coming into the archive have a DOI assigned. All right. Role 6 is funding. That's, for some people, that's the most interesting and important one, right? We're NOAA or other agencies. We have some dollars. We give them to researchers, and that's great. And we want to, fund research not only in gathering data, but also in big data analytics, in the science on the data, and so forth. There are some new requirements, though. Well, so we give people funding, and they generate data, they produce data, and they write publications. That's the traditional thing. But this memo came out in 2013 from the White House on public access to the results of federally funded research, which has imposed some new requirements. Perhaps you're already aware of them. Certainly if you're getting government funding, you should be. One requirement is to make the data accessible, which could mean depositing it in our archive, could mean setting up your own server, could mean putting it somewhere else, but in any case, making it publicly accessible in a timely fashion, which is normally a year after collection. And then also, if you write publications based on the data, deposit a manuscript, the pre-publication manuscript, into our NOAA institutional repository, where it will be made available after a 1-year embargo period. So people, even if they don't subscribe to the journal that you publish in, will be able to see at least the manuscript within a year of publication, because writing that article was done with taxpayer money, so we're trying to let the taxpayers get access to the fruits of your research. All right, so research funding, that's pretty cool, pretty key. All right, so that was 7 public sector roles labeled 0 through 6: coordination, data production, operational reliability, scientific validity, public access and usability, long-term preservation, and research funding. And that's great. So we're producing big data, we're letting people get to it, and we're trying to improve how that happens. However, and here we're getting into the kind of challenge and wish phase. A lot of users need answers, not data. And I think, in fact, the last slide, I keep alluding, Kristen, to your talk because that was the only one I saw, but you had on your very last slide a box at the top that sort of magically, creates it's like data and then answers or something. I forget what it was labeled, but yeah, insights. Okay, great. So how do we do that? Because the users, there's all this bad stuff going on, right? All these disasters, and the users do not want terabytes of floating point data. They just want to make a decision. They want to distill all of that down to 1 bit. Should I bring my umbrella today? Yes, in fact, I did. Should I permit a building to be built here? What can I do to mitigate flooding? Should I build a seawall? That kind of thing. So we really need to be able to support non-expert data users, but we don't have, the public sector doesn't necessarily have the bandwidth or all the personnel, bandwidth is what I mean, to support every single possible user out there. So how do we let that happen? I think there's 2 big challenges. One is the volume, and then the other is the complexity, people not really understanding the data. And I think the cloud providers, the private sector, is going to help a lot with the volume side of that. I think on the complexity, you're going to need expertise from the private sector as well as from academics and the public sector, and academics and the commercial sector. So I have a couple of wishes here to conclude. One is that we fully leverage the cloud. So we're already taking all of our data and sending it to our operational customers as fast as we can, and also sending it to the archive. That's great. We're going to keep doing that. But can we just send everything routinely to the cloud? We've labored to send this one NextRad data set as part of the project, and a few others are online, but for every one we have to kind of work on that to make it happen. We should be building our systems so the data go to all 3 places as a matter of course. That's just kind of built in. It's always getting there so that people can work directly on the data. That's wish 1. And then the second is somehow to enable better decision making. How do we bridge the gap between these Earth observations, these model outputs, kind of complicated science data, and then non-science users who just want to make some decisions about policy or business? There's this black box somewhere between the 2, which we call decision support tools, but and some exist. I'm not saying they don't, but there are additional decisions we need to be making and better tools for those decisions. So I see a big opportunity here for public-private collaboration on things like what are the derived information products, how do we integrate data from multiple sources, how do we do analyses that are very location-specific as opposed to kind of aggregated over the whole continent, specific analyses for use cases, statistics, trends, and so forth. So that's something I'd love to see happen more as a collaboration between the public and private sector. So thank you very much for the opportunity.